and welcome to Chemistry with Mr. Olson. Let's close this. Okay. Today we're going to do a combined gas law problem. And it's question 4 in our gas laws worksheet 2. Let's see. Things we have to remember in addition to the combined gas law. We must remember temperatures must be in Kelvin for this to work. All right. Let's read the question. Question 4. A balloon of air occupies 10.0 liters at 25 degrees C and 1 atmosphere. What volume will it occupy if it's placed in a freezer at minus 10 degrees C and the pressure is constant? Okay, the pressure is constant, so we are going to in our combined gas law, we will ignore pressure, and we're left with the following starting equation. V1 over T1 equals V2 over T2. The pressures cancel. And let's see if we can identify some variables here. The original volume, V1, is 10.0 liters. We'll call that V1. 25 degrees C. So that will be our starting temperature, T1. Now to convert to Kelvin, we take the 25 degrees C and we add 273 to get our temperature in Kelvin. That's 298 Kelvin. Okay, what volume, that will be V2, will it occupy if it's placed in a freezer at minus 10 degrees? So that will be our T2. T2 equals minus 10 degrees C plus 273, 263 Kelvin. Okay, so we want to solve for V2. V2 over T2. So if we multiply T2 by both sides, we get this new equation. V2 equals V1 T2 over T1. Just doing algebra to solve for T1. I much prefer doing algebra on variables than on units with numbers. Units with numbers I like to just write once and then cancel all those units that I can. Alright, so V1, that is the 10.0 liters. So 10.0 liters, and we'll draw a nice big line to work with. T2, substituting in the same position, T2 is 263K. Very common error is to switch numbers, switch 1 and 2 to do temperature 1 up here. And T1 is what's on the bottom, that's 298K. 298K. Now Kelvin cancels Kelvin, and we are left with the calculation. We do that on our calculator and we get 8.83 liters is the only unit left standing, and there's our answer. So 3 sig figs because we have 3 sig figs in our starting data. So the things we remember are always convert your temperatures to Kelvin, and anything that remains constant, such as pressure, that means that the P1 equals P2 and they can be canceled out, and that's how we do the gas law calculations. Hope this is helpful. Have a beautiful evening. And